single variable linear equation. This is the name of the course, and this is your first unit. I am Glenford Dawson, and I'm going to be your lecturer. So let's talk about the objectives, things that you will have learned by the end of this unit. What is an equation? What are the common terminologies that we use in solving equations? What do we mean by RHS and LHS? What does it mean when we say transpose? What does it mean to group like terms? And we're going to learn how to perform basic computations with like terms. So x plus 3 is an expression. That's merely an expression. But if you put an equal sign on there, equal to something else, it now becomes an equation. So what an equation is two or more expressions joined by the equal sign. So that makes it an equation. In mathematics, an equation is a formula that expresses the equality of two expressions by connecting them with the equal sign. So here's another example of an equation. If you have 2x plus 4 is equal to 12. There's an equal sign, and there are expressions on the left side, and there are expressions on the right side of the equal sign. I want you to take note to what I just said. There are expressions on the left side and the right side. So over here, where the 12 is, we call it the RHS. And what that really means is the right-hand side of the equation. So you can imagine what over here, the left-hand side of the equation. So RHS and LHS, you've been introduced. Let's talk about some more terminologies. Let's talk about variables to start with. So again, what if I had 2x plus 4 is equal to 12? This is an equation. I have expressions over here on the left-hand side and expressions on the right-hand side. My variable is that unknown value that I'm looking for. And it is usually depicted using a letter from the alphabet. So in this case, my unknown value is x. X is my variable in this case. In that example that I just gave, x is my variable. But we also have the 4 and the 12, but those are exact values. Those are known values. Those values won't change by the time we get to the end of the problem. Those are called constants. And you can have more than one constant depending on where you are in the problem. So in this case, 4 and 12 are constants. Now, if we were to solve the problem, we would do something and we would end up with just one constant. But at this stage, 4 and 12 are our constants. Now, if you notice, there's this number in front of the x here, right here, the 2. 2x really means 2 multiplied by x. So you don't see an operator in between here, but it means 2 multiplied by x. In that case, 2 is the coefficient. So the coefficient is that number that is multiplying the variable. that number in front of the variable. It could look like this. It could look like x over 2, which is really 1/2 x. So we're taking x and multiplying it by 1/2, and therefore 1/2 then in this case would be our coefficient. Now, while we're here, I should point out that if you have just x, the coefficient of just x is 1. Why? I don't see a 1 here, but it's silent. X is the same thing as 1x, but we don't write 1x. We don't write 1y or 1a. We just write the variable. But the 1 is there. So if you are ever asked in a question, what is a variable of y? You don't see a number in front of it. What is the coefficient, pardon me, of y? The answer is 1. Okay, so we will get into that some more. Single variable linear equation. Let's address the linear part first. We already know what an equation is. Let's address the linear part. X is not the same as x squared. It's not the same as x squared. So all our problems that we're going to be working with in this unit will have an exponent that is 1. When you have x to the first power, we don't write that, we just write x. So you will have a, or y, or m, or z, but you will not have to deal with a squared, or y squared, or m squared, etc., etc. We're going to deal only with linear. Linear means that the power of the variable is 1. So what do we mean by single variable? Well, we know what single means, and we know what variable means. But let's look at a multivariable equation, and that will give us an idea of what a single variable equation is. So if I have x plus 2y is equal to 3, and I'm to list out my variables, I have x, that's an unknown value, y, that's an unknown value, so those are already 2 variables. So we say that's a multivariable equation. Now, we're not interested in that, which is why I'm not making a note of that. I'm going to use that to demonstrate to you the difference between that and a single variable equation. A plus 7 is equal to 12. There's only one variable here. This is a single variable equation. It's a single variable equation. Even if I had multiple instances of the same variable, it's still a single variable equation. What do I mean by that? What if I had 4m plus 7 plus 7 is equal to 2m minus 6. Now we're going to learn how to solve these. I'm not asking you to do that right now. What I'm asking you to pay attention to is the fact that there's an m here, m term, and an m term here. But those are the same terms. We can group them, and we're going to learn how to group them. But it's still the same m. It's still the same variable. So it's still a single variable linear equation. So what's our goal in these? Our goal is to somehow end up with something that looks like this. A is equal to something. Now we have finished. Which means if you're at a point where you have 2a is equal to 7, no, we're not finished. Our goal is to get the variable that we're trying to find on a side by itself. This has 2 on it with the a. That is not by itself. If I have minus x is equal to 12, no, I am not finished. I am not finished because I want to see x is equal to something, not minus x. It means there's more work to go. So our goal is to get the variable on the side by itself being equal to something. Grouping like terms. So I showed you earlier a case where we had multiple instances of a variable. So if I had p plus 4 plus 3p. Now I can see that p and 3p are p terms. They're the same type of term. 4 is a constant. So to group them, I'm just going to bring them closer together without changing their signs. So I'm going to say this is going to be equal to p plus 3p. Now this plus came from this 3p. It's not because of this plus. This plus is for this 4. So now I come plus 4. Now we're going to come back to this in a minute, okay? If I had a plus a, that would be 2a. If I had 5x minus 2x, that would be 3x. Notice what I'm doing here. Because it's the same variable, I can just add or subtract them. They're apples and apples, we say. So if I have an a and I have another a, then I have 2 a's. Remember, secretly there is a 1 here and there's a 1 here. We just don't write the ones. So this is 1a plus 1a, so just add the 1 and 1. Similarly here, this is 5x minus 2x. Because they're both x's, I'm going to get something x. So I just subtract 5 minus 2. Okay? So that's how we perform computations on like terms. Like terms refer to the fact that this is a p term and this is a p term. So those are like terms. Like terms. So now p plus 3p is really 1p plus 3p. So this is 4p plus 4. Now what I've done here is simplify by grouping. Simplify by grouping. In other words, those are the instructions you would get if you had such a problem to work, which you do know. You have 2 of them. So the first one you have to do is 3x plus 5 plus 6 plus 2x. And the second one you have to do is m plus 4 minus 4 minus 4m plus 6. So what you want to do is you want to pause the video and give these a try. So let's look at the first one. Let's look at the first one. So we have 3x plus 5 plus 6 plus 2x. So now I want to group the like terms. So I see 2 different types of terms here. So what I do is I identify the types of terms. I see x terms. I see 2 of those, but they're both x terms. And I see constants. So I'm going to group them, which means bring them together. This is before I perform any computation. So this now is 3x plus 2x. Again, this plus comes from here, comes along with the 2x. Then I have plus 5 plus 6. And then right here, I can add these 2 because they're the same term. So then this becomes 5x plus 11. And that's the answer you should have gotten. So this is simplified by grouping. All right, so you want to pause it and try the second one if you haven't as yet. I'm actually going to do the second one right underneath here, actually. So I'm going to group these right here, and I'm going to have M. Notice this is now a minus 4M. So remember I was telling you earlier that this sign that I put here comes from here. It does not come from what comes after the M. Okay, so M minus 4M, and now plus 6. Sorry, that should be plus 4 plus 4 plus 6. So M minus 4M is really 1M, right? So this is really a case of 1 minus 4. 1M minus 4M, and 1 minus 4 is minus 3. So then this is minus 3M. Can't forget the variable, plus 10. Okay. All right. So this is a good time to take note that if you're not very up to date with your negative and positive integers and how to add, subtract, divide, and multiply them, you want to get that reviewed. And you can get some help with that right here. We have a bunch of videos on YouTube, right? So make sure you come right here, subscribe, follow us on Instagram, add us on Facebook, all right? So your objectives. At this point, you want to make reference to your objectives and make sure that we covered everything. Also, you want to make sure that the notes that you have pertain to everything. You should have a piece of note for everything that was a part of your objectives. Okay. Now, what I did in this particular unit is I took some notes, some sample notes to give you an idea of the things that you should have in your notes, and you could download that. And there is a link for that on the course website. Okay. And we've come to the end of Unit 1. Here's a short quiz on the material that we've covered here. Pass the mark to 70%. Get that done, and I'll see you in Unit 2.